Hi, 8th graders. Mr. Hescock's back with your next lesson on, this is chapter 10, section 2. We're going to start talking about speed and velocity today. First section was all about what is motion. Motion is change in position. Let's talk about your homework from just the other day. First question was, to specify the position of an object, you need to know a reference point. Latitude and longitude they measure position. A person moving on a train sees a car that appears to be stopped. A person outside the train sees both the car and the train moving. This example shows that is an example of relative motion. It is relative to the frame of reference. In the last lesson, we talked about frames of reference, whether your stationary or your frame of reference could be moving. Which tells you how quickly an object changes direction. That is speed. Why is it important to choose a frame of direction when you observe motion? You must choose your frame of reference relative to your motion and the object that you are looking at. It was also the last one there. So that was pretty quick, pretty easy. Let's go on to the next section. Remember, ladies and gentlemen, you've got to go back, fill in your notes, watch the video clips at home. I put the video clips in on purpose to add to this. Your work after you're done with this lesson, you're going to read 318 to 319. Remember, it is in the material section of the Google Classroom. The worksheet assignment will pop up. So let's get going. Speed measures how fast an object changes position. Position can change at different rates. Speed is the measure of how fast something moves or the distance it moves in a given time. One can calculate speed by dividing the distance moved by the time. Distance is almost always in meters. Time is usually in seconds or hours. If Mike is skateboarding and travels 9 meters in 2 seconds, what is his speed? Well, let's work that one out. Nine meters divided by 2 seconds gives you 4.5 meters per second. Average speed is more common than instantaneous speed because you don't travel at the same speed your entire time. Very shortly, you're going to see a video clip that I filmed outside of a 10-meter run. You started at 0. My son's going to start at 0 and ends at 10. He is not traveling the same speed at the 0 mark that he is at the 10, so we're doing what we call an average speed. Hi guys, we're going to talk about speed here. Speed is distance divided by time, where S is equal for speed, D is distance, and T is time. What better way to learn about it than one of the most common tests? I have set up a 10-meter sprint for my lovely assistant Bryson. And what we're going to do, I'm going to take my stopwatch out on my phone and set the timer here. So Bryson, go ahead, get there at the starting point. At the starting point, distance is 0. At the final point at 10 meters, this is the final distance, we're going to take the time. All right, for those of you playing along at home, he ran that in 2.58 seconds. For our purpose, we're going to go ahead and round that. Speed is 10 meters divided by 2.6. traveling at about 3.8 meters per second. Distance versus time graphs. These show distance over time. You'll see these very often on your standardized tests. So this is distance here, this is time. You'll see a line like that. That is showing you positive speed, and that object is moving usually away from you. If you see a straight horizontal line on a distance versus time graph, the speed here, because there's no slope, is 0. If you see a slope that is heading down, this is negative speed, or coming towards you. A motorcycle traveled 100 miles south for 3 hours. What is the average velocity? 100 divided by 3. You get 33 1/3 miles per hour. And then here's the solution. Velocity is just slightly different than speed. In my demo video, the one that you just watched, Bryson ran from the eastern side of the street to the west. So he was actually running west at 3.8 meters per second. West gives you a direction. Velocity is what we call a vector. This is not the same as the vector that's in Despicable Me, although that's where he gets his name. This can be as simple as being positive or negative, in a positive direction or negative. It can be north and south. It can be several different ways of adding it to be a vector. If a woman has walked 6 kilometers in 1 hour while traveling east on 6th Avenue, she has actually had a velocity of 6 kilometers east. You've got to have the direction to make it a vector. We'll talk about those when we get together online. Velocities can be added. If you paddle a canoe with the current of the stream, meaning if you're heading downstream and you're paddling at the same time, the stream is pushing you, plus you're paddling at the same time, you're going to go faster. So let's say here's our canoe. And your canoe is moving at 3 meters per second, but the river itself is moving at 6 meters per second. Our total speed in this case, in that direction to the right, is 9 meters per second. At the same time, if vectors are in opposite directions, if you want to go back upstream, if I want to paddle backwards and you can only paddle at 3 meters per second, you are still going to be losing ground. You subtract these, 6 minus 3, you're actually going to be heading the wrong direction at 3 meters per second in the direction you don't want to go. Velocities include direction and a size. It could be acceleration. There are other types of vectors too. Two objects can have the same velocity and not have this, or can have different velocities and not have the same, or have the same speed. I'm gonna cut all. Two objects can have the same speed but not the same velocities. You could be going 6 kilometers per hour north and another person can be going 6 kilometers per hour east. The speeds are the same, The velocities are not. A man in a kayak is paddling upstream at 6 kilometers per hour. The river is flowing at 4.5 kilometers per hour. Your actual velocity here, you subtract, you get 1.5. All right, ladies and gentlemen, that will take us to the end of this second section. There is reading 319 to 328. You guys are going to have that worksheet to do. If you have any questions, make sure you get a hold of me in Teams or on the Google Classroom. And until next time,